Hello friends, welcome to Mosdi Physics. Today I will run through a quick one on forces on a substance. Majorly I'm talking about upthrust, tension and weight. So a very quick one here before we attempt the question. We need to understand some basic concept on forces. Now the first one is talking about the forces that act on the surface of a liquid. Let's assume we have a bucket filled with water. A bucket filled with water like this, and we have a solid that is thrown inside the bucket. So the solid is this, and everything is immersed. As you can see, we have the weight of this solid now is acting vertically downward as the weight of the solid. We have the upthrust of the solid is an upward force as the upthrust, which we call U as the upthrust, and we have the weight of this water, which we call the apparent weight, that is acting on top. The apparent weight here, which in physics is called so-called apparent weight, which people call tension. So without wasting time, what we understand in physics is that the tension, which is the apparent weight, tension or apparent weight, is equals to tension of apparent weight now is something as the weight of the solid minus the upthrust. So that is the only thing we need to understand here. So what I'm saying is tension is the weight of the solid minus the upthrust. So now that's the first thing. And the second thing we need to understand is that the upthrust force is also called the loss in weight. The loss in weight of the solid that was dropped inside this water. So upthrust nearly is given by the formula V rho G. V rho G. Whereby V stands for V is called the volume of the solid that is immersed, the volume of this solid that is dropped in water. Rho is the density of the fluids, which can be kerosene or any other material, the liquid, and G is the acceleration due to gravity, which we all know to be constant. So what I'm saying in essence here in this short video is for us to understand here that upthrust is the V rho G. V stands for the volume of the solid immersed. P stands for rho. This thing is called rho, which is density. Let's let it be known as this density. And G is acceleration due to gravity. So knowing this, that tension is weight minus upthrust. Then tension is also called apparent weight, where upthrust is called the loss in weight of the solid. So I have some couple of questions I want us to try. I'll do two. Then you guys can try this third one and send the solution answer to my WhatsApp page or the comment box of the YouTube page. Now here we have the first question. The first question was actually extracted from JAM 1980 question 29. We have an object of mass M, volume V, is totally immersed in a liquid of density rho. The tension of the string holding it is dash. So from my explanation, I made you guys understand that tension is equals to the weight minus upthrust. And also from my explanation, I made you guys understand that upthrust equals to what I call V rho G. So when you substitute that, tension is weight minus upthrust is V rho G. And from your knowledge of physics, you know that weight is a mass times acceleration due to gravity. So if you finish that from here, you're going to have from here, please watch, tension will be equals to mg minus V rho G. And when you watch the option, you can see G is common, factorize. Tension will be, you have G open bracket M minus rho V. And when you watch that, that is the same thing as choice C. So the first answer to 9080 question 29 is choice C. Very, very simple to solve. The second one, quick one. The second question is also actually extracted from JAM. I think this is 1993 question 13. So we have an object of mass this side, an object of mass. Object of mass is a 400 gram, which you need to convert to kilogram. You know that's 0.5 kilogram, and density of 600 kilogram per meter cube. That means rho is 600 kilogram per meter cube. Is suspended with a string so that half of it is immersed in paraffin of density 900. So the density of the fluid here, you have to understand, is 900 kilogram per meter cube. So the examiner asks for tension. Tension is the question we're looking for. Just like what we did the other time, we know that tension is equals to weight minus upthrust. And we know upthrust formula to be equals to weight minus, we have V, that's volume of the solids, rho G. Hereby, rho is for the fluid. Let it be known. So now, without wasting time, we know that tension here is weight from what we did is mg. Mass is 0.4 times 10 minus. Now we have to understand from here, half of it is in mass, not all. So half of the volume of the solid times the rho. The rho of the fluid is 900 and G is always 10. So without wasting time, we can finish this and say tension will be equals to 0.4 times 10, that's 4, minus half of volume of the solid immersed. Half of it is immersed. So volume from our density equals to mass over volume. You know that volume will be equals to mass over density. So the mass given in the question was 0.4 and the density of the solid was 600. 10 times 900 times 10. And if we go by punching our calculator, tension here will be equals to 4 minus, when you punch half of 0.4 divided by 600, you are going to get, we can do a little mathematics here by saying, okay, half times 0.4 over 600 is something as saying 4 over 10 times 1 over 600 and times 900 times 10. All this, when you got tension will be equals to 4 minus here 1, here 2, here 1, here 5. You can continue this, here 1, here 2, then we have this, and that is 3. So everything here is given us a here 1, here 3, 3 here 1, 3 here 3. When you cut that, 4 minus 3, and the final answer should be 1 Newton. So the right answer to that one should be 1 Newton. Even here when you punch your calculator, you can actually get that without wasting time. So the correct option to that should be choice A. So, and a very quick one here, question 3, which I want you guys to try and give me the answer under the comment section, is more or less like question 2 I solved here. So just follow the same step, but this time it is 1/5 of the volume of the solid that was submerged. I'll be waiting for your answer. See you guys soon. Thank you.